Alpha Centauri is our closest star system. You could say that on a cosmic scale, it's just a few steps away. This binary star system is located about 4.376 light years away from us, where even light takes more than 4 years to reach. But Alpha Centauri is our neighbor. It's quite close. We have discovered star systems and their exoplanets that are much farther away than this. The number of exoplanets is more than 5,000, but even after repeated astronomical surveys in our neighboring star system, we have failed to find any extrasolar planet there. And the biggest reason for this is this entire star system. It becomes quite difficult to find any planet present around them. Many times we thought there was a planet there, but either there was no planet at all, meaning we got false positive results, or we were never able to confirm those planets for orbit locus interferometric monitoring of our. Keeping this in mind, in 2019, that is Toliman, and this is also the ancient Arabic name of Alpha Centauri. How this mission will search for exoplanets around Alpha Centauri, that's what we will learn in today's video. This mission will be completed at a very low cost, and it has been designed by a team from the University of Sydney, and its aim is to search around Alpha Centauri. To search for potentially habitable planets by the astrometry method. In this method, the apparent position of the star is continuously monitored to see if the star is wobbling. If yes, then where is that gravitational force coming from? For example, from a companion star or from a planet that is orbiting it. We already know quite a lot about Alpha Centauri. The primary star of this whole system, that is the G-type primary star, is very much like our Sun. It's a G-type primary star, and the secondary star is an orange dwarf, that is a K-type star. But because of its binary nature, the signals coming from this star system, the rest of the When a planet passes between our telescope and the star, the light coming from the star decreases, which allows us to detect exoplanets using this method. But here, both stars are transiting each other. Here, it becomes quite difficult to understand which one is affecting the other's movement, and in this way, we can also detect the movement of planets orbiting around the stars. This method is called the radial velocity method, and it was through this method that we confirmed the existence of Proxima b, which was discovered in the habitable zone of the Proxima Centauri star. After this, around this star, Proxima b planet was discovered, the innermost planet, which is about the size of Mars, and the outermost planet, which is a gas giant. It is estimated to be similar to our Saturn. Just like Alpha Centauri's binary star system, Alpha Centauri is a bit similar, with a ringed planet. That was about Proxima Centauri, and there have been some indications. The first signal we received is a bit different from Alpha Centauri's binary star system. It's from an RV Centauri. Later in 2015, it was revealed that the Alpha Centauri BB RV signal was a false positive. Similarly, in 2013, an announcement was made about a possible planetary transit. When more reports came in about this, we found out that even if this planet exists, it would be so close to its star that imagining life there is impossible. In 2021 as well, there was talk about a planet named Jeevan existing in the orbit of Alpha Centauri. This planet was discovered using a new method called direct thermal imaging, but it still hasn't been confirmed to this day. Peter, a physics professor at the Sydney Institute of Astronomy, who is also leading the Toliman project, he says that confirming planets around these binary stars is a difficult task. They are extremely close to our home. Astronomers have discovered thousands of exoplanets outside our solar system, but most of them are thousands of light years away and completely out of our reach. In today's era, modern satellite technology will help us explore our nearby cosmic neighborhood, and the Toliman project is one of them. In this, unlike a conventional telescope, the light coming from the star will not be concentrated at a single point. Toliman will use a diffractive pupil mirror pattern which will transform the light coming from the stars into a very complex flower pattern. And if there are extreme and clear indications of an exoplanet, they will be followed up with a more powerful telescope. During the follow-up mission, telescopes like James Webb will lead the study of its atmosphere, surface chemistry, and even the biosphere's fingerprints there. Or this task will be assigned to the Nancy Grace Roman Space Telescope, which will be launched in 2027. And the 30-meter ground-based telescopes on Earth also consider the Alpha Centauri star system a popular target. But before all of this, we will have to launch the Toliman satellite. And the University of Sydney has signed a contract with a company called Endurosat for this, which makes microsatellites, space services, delivery systems, and custom-built mini-satellites. For this mission, a mini-satellite will be built with a delivery system which will have a downlink speed of about 125 Mbps, which in itself is a big deal. This telescope will be launched by the end of 2023. And then maybe we will be able to uncover the mysteries of the signals coming from Proxima and Alpha Centauri. This is a big hope for us. And for SETI as well, it is possible that we might find signs of life in our neighboring solar system. And then, through the upcoming mission Breakthrough Starshot, we can confirm it. Alpha Centauri is not just a single star. Rather, it is a system that is full of complexities and wonders. It has three major celestial bodies. Alpha Centauri A is a star that is just like our Sun, and it is officially known as Regal Centaurus. The second star of this system is Alpha Centauri B. It is also called Toliman, and the last one is the mysterious Alpha Centauri C, which is also known as Proxima Centauri. This is a red dwarf that orbits around both of them at a distance of 0.2 light years. A lone wandering star that is right at the edge of its stellar family. Proxima Centauri has a secret. A planet named Proxima b. It was discovered in 2016. This rocky exoplanet is very close to its star, just 0.049 astronomical units away. But still, it is in the habitable zone of Proxima Centauri. So, can this be a second home for humanity? Is it possible? Or are there some conditions here that will keep this planet shrouded in mystery forever? Proxima b is our closest known exoplanet. It's only 4.246 light years away. In cosmic terms, that seems really close. But being this close still means a distance of 40 trillion kilometers. That's such a huge distance that even light, which is the fastest thing in the universe, even light takes 4.3 years to cover this distance. For humans like us, who exist in this universe for just a few moments, who are bound to their slow spaceships, this challenge becomes even greater for us. Reaching Proxima b is not just a journey, it's like making a bet with the impossible. So then why do we dream of Proxima b? Maybe because it's a mystery waiting to be solved. A part of a puzzle that fits perfectly into the grand narrative of our existence. But before we set foot on this unknown land, we have to face a harsh reality. A reality that asks us questions we might be afraid to face. But we are here to set foot on unknown land. Just think about it. The distance to Proxima Centauri is 266,000 times greater than the distance between Earth and the Sun. It's about 103 billion times greater than the distance between Earth and the Moon. Voyager 1, which is humanity's fastest interstellar spacecraft, would take 103,750 million more years to reach there. By then, maybe our civilization or even we ourselves would have long forgotten that we ever launched probes called Voyager. The record-breaking Parker Solar Probe, which travels at a speed of 700,000 kilometers per hour, would also take 65,000 years to complete this trip. These numbers are not just frightening. They remind us that reaching Alpha Centauri with technology is not a simple challenge. It will be a journey that will demand breaking and surpassing the limits of physics, engineering, and human imagination. And yet, as we gaze into this infinite universe, a strange question arises. Are we meant to cross it, or are there parts of the universe we shouldn't unlock? The Barrier of Light, a Cosmic Conspiracy. In 1905, Albert Einstein changed the way we understand our reality with his special theory of relativity. One of the major mysteries of this theory was that any object with mass cannot surpass the speed of light to reach Alpha Centauri. This is not just a suggestion, it's a challenge. No one can reach Alpha. That limit is woven into the fabric of space-time itself. When an object accelerates, its energy turns into mass. The faster it moves, the heavier it becomes. Then a time will come when it will need infinite energy to go even faster. Just think about it. If an astronaut reaches 99.9% the speed of light, his 80-kilogram mass will increase to almost 2 tons. The closer you get to the cosmic speed limit, the bigger the challenge of increasing speed becomes. Crossing the speed of light is like jumping over a wall of infinite height. Nothing can take you to the other side. Even if we reach the speed of light, the journey to Proxima Centauri will still take about 4.3 years. But this is just a best-case scenario, a dream that seems almost impossible due to vast energy requirements and the laws of physics. Reaching such speeds is not just a technological challenge. This is a battle against the very nature and principles of reality, one that is impossible for us to win. A glimmer of hope, time dilation. And yet, this universe is full of paradoxes. When a spaceship travels close to the speed of light, a strange phenomenon occurs: time dilation. A spacecraft traveling toward Proxima Centauri at relativistic speed experiences time passing more slowly for its crew. For an observer on the ground, this journey may seem to last for decades or centuries, but for the travelers inside the spacecraft, it will feel like just a few years. But time dilation is not just a subjective compression. Imagine from the perspective of an observer on Earth, a spacecraft that reaches 95% of the speed of light. It will take years, but for the crew, due to time dilation, this journey will feel like only 1.39 years. The faster the spacecraft travels, the smaller this difference becomes. But if the spacecraft travels at 99.9% the speed of light, then for the crew, a 1-year journey will only feel like 2 weeks. And if the speed reaches 99.9999% the speed of light, then a journey that would take thousands of light years would be completed by the crew in just a few decades or even less. This phenomenon raises a profound question. Can relativistic travel open the path to interstellar exploration? Maybe, but time dilation is not a miracle. Reaching such speeds for relativistic travel is also unimaginable for interstellar journeys. And the dangers involved? Such as collisions with high-energy particles, lethal radiation, and destructive interactions with interstellar matter. All these challenges are still very significant. At such speeds, even a thin layer of interstellar gas would turn into deadly plasma for both the spacecraft and its crew. The empty space, which once seemed calm and completely empty, would become an invisible battleground, a battlefield where no spacecraft has survived so far. Time dilation does promise to take us to distant stars, but it also brings with it deep and mysterious barriers. The limitations of time dilation, as we saw earlier, mean that taking a mass close to the speed of light would practically require infinite mass. So far, we haven't found any propulsion system that can make this possible. And even if we somehow solve the problem of energy, space would still become a very dangerous place for a spaceship traveling close to the speed of light. Space isn't empty, it's actually filled with countless wandering atoms which sometimes gather in complex forms as gas and dust clouds, galaxies, stars, and planets, and sometimes exist as lone atoms. In this infinite universe, the probability of a collision between two hydrogen atoms keeps fluctuating, and during the spaceship's journey, the certainty of an enormous flow of these atoms colliding with the spaceship is a completely different matter. At low speeds, these particles are harmless, but with acceleration, they rain down dangerously as projectiles and highly penetrating ionizing radiation, which can cause severe damage to the spacecraft. Because of the projectiles and the highly penetrating ionizing radiation, the atmosphere becomes radioactive for the spaceship. Particles traveling at speeds close to the speed of light acquire so much energy that they become a threat to any form of life. At such high speeds, even passing through a very thin nebular cloud can destroy the entire spaceship. Social and temporal disconnection, a lonely extreme. Even if we overcome all the technical challenges, an impossible problem will still remain. Time dilation will have a devastating effect on the relationship between the spaceship and the home planet. For the crew aboard a relativistic ship, time will slow down drastically, but on Earth, the clock will keep ticking at its usual pace. What feels like just 11 years for the crew will turn into hundreds of thousands or even millions of years for the people left on Earth. This harsh truth presents us with an existential dilemma. Astronauts who embark on such a journey will have to leave their world, family, friends, and even their culture behind forever. And when they return, Earth will have completely changed for them, or perhaps it may not even be habitable anymore. The society they once left behind will have been lost in the sands of time, or perhaps transformed into something alien. Or it might have completely ceased to exist. The spaceship would no longer be a means of exploration, but would become a small, lonely world drifting through time and space. The necessary impact of such temporal isolation. What motivation would even Star Trek's fictional United Federation of Planets have? Would anyone have the motivation to send cargo on such a journey where there would never be any connection with the sender again? Such a journey would not be a transaction, but rather cargo that has neither an owner nor a destination. According to the laws of Einsteinian relativity, any spaceship embarking on such a journey would actually become a self-sustained world, completely separate from its origin, drifting away from its purpose. So, would this sacrifice be worth it? This sad conclusion. This aligns well with Fermi's famous paradox. If advanced civilizations exist, then why haven't we encountered them yet? Perhaps the answer isn't that they don't exist, but rather that the harsh reality of this universe's laws is right in front of us. Even if we overcome these barriers, for the crew of a relativistic spaceship, time on their planet will continue at its usual pace. Generations will pass, civilizations will rise and fall, and by the time the crew returns, their world will have completely changed for them, or perhaps even ceased to exist. So what would be the purpose of such a journey? A mission to Alpha Centauri is not just about crossing physical space. It would break the bonds of time and memories that connect us to humanity, that make us human. The Fermi paradox, a stark reminder. This conclusion leads us to a frightening and profound question once asked by Enrico Fermi. If advanced civilizations exist, then why haven't we encountered them yet? It's embedded within civilizations that we encounter. The distances between the stars are not just measurements of space, but act as strong fortresses of isolation. These are barriers created by nature itself, and perhaps very few would ever try to break them. These barriers might confine every civilization to its own celestial backyard, where dreams of interstellar expansion burn like a fading flame and eventually die out. Alpha Centauri, despite being our closest neighbor, remains a dream only for those who are truly courageous. Does this fact, which points to the non-existence of visitors, indicate the defeat of all those civilizations? Or is it an even deeper warning that we are truly alone in this infinite darkness? A new hope, robotic explorers and light sails, but we know that where humans cannot go, there. The future of interstellar exploration may belong to robotic probes, miniaturized marvels. The future of interstellar exploration may be in the hands of robotic probes with concepts like von Neumann probes that can self-replicate and colonize. We can spread the essence of humanity to the stars, or perhaps with laser sails. These will be driven by focused light beams. By accelerating lightweight probes, they can reach up to 20% the speed of light, and with this, we could reach Alpha Centauri in just 21 years. These solutions are not part of science fiction, but are actually very close to our reality. Even so, this journey will not be easy, and the obstacles are huge. But humanity has never shied away from doing the impossible. Will these machines one day send us secrets we never even imagined? Conclusion: the eternal mystery. Alpha Centauri has always been a puzzle, a mystery at the edge of human reach. It inspires us to search for new worlds, but at the same time, it reminds us of our limitations. Whether we reach it in a century, a millennium, or perhaps never at all, the dream of Alpha Centauri will always inspire humanity to look up at the sky, to ask questions, and to move forward. In the end, facing the universe and trying to explore it is not just about the attempt itself, it's about searching for meaning. Are we meant to remain strangers here? Or maybe one day we will become connected with these stars. In this mysterious darkness, there is one star that has amazed scientists. Its name is Case 8462852, but the world knows it as Tabby's star. This star, shining in the Cygnus constellation about 1,470 light-years away from our Earth, has remained in the spotlight because of its strange behavior. Everyone was amazed to see it. How could a star dim by up to 22% and then suddenly start shining again? All of this happened so irregularly that scientists involved in the search for extraterrestrial intelligence have focused their attention on this star. There was no solid answer to this, but the most mysterious thing about it was why SETI, the search for extraterrestrial intelligence, was paying so much attention to this star. I'm going to tell you the strangest story, a story that will take you into the world of stars, and then only one question will arise in your mind. Are we really alone in this very strange universe? The story of Tabby's star's citizen scientists began in 2015 when NASA's Kepler Space Telescope observed something like this star. Not at all. Usually when a planet passes in front of its star, it dims the light by 1 or 2%, and that too in a predictable time period. But Tabby's star's brightness was sometimes dropping by up to 22%, and that too without any pattern. It was as if something unpredictable was forcing us to think, was it just dust, or was it something that could possibly be alien? Tabby's star, also known as Boyajian star or WTF star, meaning where's the flux, is an F-type main sequence star which is a bit bigger and hotter than our Sun. It's located in the Cygnus constellation, about 1,470 light-years away. Back in 2015, astronomer Tabitha Boyajian and her team, while analyzing Kepler's data, found that the brightness of this star was decreasing irregularly and unusually. Some dips were so large that they couldn't be caused by any planet, because even giant planets like Jupiter, if they pass in front of the Sun, can only dim its light by about 1%. So then, what exactly is happening around Tabby's star? Several possibilities were explored for this. Maybe it was a swarm of comets passing in front of that star, or maybe it could have been some interstellar dust which was coming between the Earth and the star, or maybe it was the star's own internal fluctuation, but none of these theories were fitting completely, and then a suggestion came forward that grabbed the attention of the whole world. Could this be some kind of alien megastructure? A theory called Dyson Swarm, a massive structure built by some advanced civilization. When the news of Tabby's star's reaction spread throughout the entire scientific community, SETI immediately turned its Allen telescope array toward this star. They were searching for radio signals that might be coming from an intelligent civilization, but they didn't find any. Still, SETI kept their eyes on this star. In 2016, when the star's brightness started to decrease again, SETI's scientists investigated even more deeply. So the Las Cumbres Observatory Global Telescope Network started its investigation. Tabitha Boyajian launched a Kickstarter campaign. Seeing the interest in the star, many questions arose in people's minds. If this is just a normal star, then why is so much attention being given to it? Did SETI suspect something that they weren't telling the world? Some people said that maybe SETI had received a signal that they didn't want to make public. If this really was an alien megastructure, then this discovery could change our understanding of the universe forever. But SETI's silence kept deepening this mystery. The biggest puzzle of Tabby's star was the irregular dips in its brightness. These dips were not regular. Sometimes the brightness would drop only up to 0.3, sometimes it would stay dim for several days, and sometimes it would suddenly brighten again. In 2017, astronomers observed that these dips were also different at different wavelengths, greater in ultraviolet and less in infrared. This meant that whatever was blocking the light from this star, so scientists were now reaching a conclusion. But where was this dust actually coming from? Some scientists believe that it could be circumstellar dust orbiting around the star, but there were many problems with this theory as well. The high radiation pressure around the star is so intense. How is this dust able to sustain itself? Why is it so irregular? If it was interstellar dust, then why didn't we see infrared emissions which we usually observe when looking at dust? Meanwhile, other scientists suggested that maybe it was a swarm of comets. But even here, no theory was fitting perfectly for what was passing in front of the star. And although the idea of an alien megastructure was unlikely, it was still stuck in people's minds. When no theory could fully explain the dimming of Tabby's star, one thought remained. In 1960, physicist Freeman Dyson proposed a theory that an advanced civilization could build massive structures to harness the energy of their star. Like a massive swarm of solar panels called a Dyson swarm. Was the dimming of Tabby's star caused by such a structure? This idea was so exciting that SETI took it seriously. Astronomer Jason Wright suggested in 2015 that the dimming of Tabby's star could be due to a partially constructed Dyson swarm. SETI increased their radio and optical observations. They also searched for those narrow-band radio signals that could indicate the presence of an intelligent civilization there. But no signal was found. SETI's interest in Tabby star was a mystery in itself. Usually SETI examines any star, and if they don't find anything, they move on. But that didn't happen with Tabby star. In 2017 and 2018, when the star's dimming was observed again, SETI kept their eyes on it. No radio signals were detected, no laser pulses, no evidence, but still SETI's persistence raised questions. Were they looking for something that was not normal at all? Some people said that maybe SETI had received a signal, but it was so strange that it was hard to understand. It was so disturbing that before bringing it to the world, they wanted to be completely sure about it. We're not saying it was a conspiracy, but when so much attention is given to a star and still no clear answer is found, questions naturally arise. Is there really something there that might be beyond our understanding? The story of Tabby's star brought us to a point where science and mystery meet. Everything that has happened so far has kept the mystery of this star alive forever, but now this mystery was about to be unveiled. As scientists gathered more data, the picture of the star's mystery started to become clearer. In 2018 and 2019, Tabitha Boyajian and her team analyzed data from the Las Cumbres Observatory, which further strengthened the circumstellar dust theory. They suggested that this dust might have been formed from the collision of an asteroid or a comet, maybe a very large asteroid. It broke apart into fine pieces which are now orbiting around the star, or maybe it was something that wasn't emitting any infrared emissions. The discoveries about Tabby's star were pointing towards one thing. The cause of Tabby star's dimming was not some alien megastructure, but rather natural dust. Some people believe that the dimming of Tabby's star was so unique that it was a perfect test case for SETI. If there was an alien civilization, did not show any interest. We're not saying that SETI is hiding something, but its silence and repeated investigations raise questions. If it was just dust, then why were so much time and resources spent on it? But this remained just a question. The story of Tabby star is not just about the dimming of a star, it's also a story of our own curiosity, the curiosity that compels us to look towards the stars. Aren't you searching for something too? Because we want to know if we are alone in this universe? Because we want to understand where our place is in this infinite space? Tabby star showed us for a moment the dream that maybe somewhere far away there is a civilization that looks at the stars just like we do. But the truth is that the mystery of Tabby star has now mostly been solved. Asteroids, dust, or exomoons, these natural causes explain its dimming. The idea of an alien megastructure was really exciting, but now it's just a scientific footnote. But still, this story teaches us a lot. It shows us how powerful our curiosity is. Every time we look at a star, we look for a new possibility, and every time we don't find answers, we search for them with even more courage. If you like this video, friends, what do you think? Will we ever be able to find an alien civilization? Be sure to share your opinion with us in the comment section below. If you like this video, stay tuned for another exciting new video. Goodbye for now.